Okay, so we're going to take a look at what will appear to be a monstrous integral. All right, these right here are kind of fun. All right, I say kind of fun because you need knowledge, okay? You need knowledge of those formulas that you probably learned in pre-cal. So I'm looking here and I see a square root of 1 minus a cosine of 2x. I'm thinking double angle here for a second, but this is actually a half angle formula. It's a half angle formula. So what we're going to do is we are going to recall from pre-cal a half angle formula. So let's recall the following, all right? And then it may make some sense. I'm going to start off with the sine squared of x, and I know that the sine squared of x equals 1 minus the cosine of 2x, all divided by 2. So knowing this, I can rewrite the identity to say then I have 2 sine squared of x equal to 1 minus the cosine of 2x. Right, so that half angle identity right there from pre-cal is going to save us right now in this problem because I'm going to rewrite this. All right, so I'm going to rewrite this integral from 0 to pi, and it's a definite integral. The 1 minus the cosine is what's going to change. So this right here is going to change. All right, and that's what we're going to work with on our integral. It is going to be the square root then of 2 times the sine squared of x dx. Now I have made this very simple for myself because the square root of 2 I can pull out, but the square root of sine squared is just sine itself. All right, it's just sine. I'm going to think about this in terms of absolute value. I only want to consider in this case the positive cases because I'm going from 0 to pi, right? And when you think about it from 0 to pi, and I'm going to make this note for you, sine is actually positive, okay, on the interval from 0 to pi. Okay, so we actually don't need the absolute values there. All right, but I just wanted you to consider that for a second. So it is the sine, let me switch up my pen here. It is the sine of x, okay? And that right there is a very straightforward integral, all right? It is a negative cosine of x. So we have that square root of 2 in play there, all right? We have that square root of 2. So the integral works out to be a negative square root of 2 cosine of x, evaluated from 0 to pi, all right? And so there's not much more to do here. What do we get? Well, I'm going to write the negative 2 on the outside. All right, I'm going to write cosine then of pi minus the cosine of 0. All right, cosine of pi, when you think about the unit circle, is just negative 1. Cosine of 0 is 1. All right, so what do we get? We get a negative 1 minus 1. We get a negative square root of 2 times negative 2. Final answer, 2 square root of 2 for this integral. All right, really nothing to it. You just have to know the identities. All right, we're going to take a look at another example here, and we're going to call this one problem number 5. All right, problem number 5 here. Now this one is going to look very similar to the one we just did, but it's going to work itself a different way, and you'll see what I mean in a second. So pi over 3 to pi over 2, and this one is going to be the square root of 1 plus the cosine of x dx. So it looks similar, but we don't have an identity necessarily for 1 plus the cosine. So what I'm going to do is I'm going to multiply by the concept of the conjugate. Okay, so I'm going to multiply by the conjugate. So let me go ahead and let's see. I'm going to erase this dx, but I'm going to put it back, don't worry. I'm going to multiply it by its conjugate, and that is the square root of 1 minus the cosine of x over the square root of 1 plus the cosine of x, just like that. And that means that this is going to be written over 1, and then I'll write my dx right here. Okay, so that changes things up just a little bit, but it's going to be very nice because you're going to see in a second what I'm trying to accomplish. So let's rewrite the integral from, I keep wanting to write 0, but it's pi over 3 to pi over 2, and you're going to have the square root on top of 1 minus the cosine squared of x, that was the whole purpose of writing it as the conjugate, over the square root of 1 plus the cosine of x. And you're going to see where this is headed towards in just a second. All right, well, I know that 1 minus the cosine squared is actually a Pythagorean identity. Okay, so again, that pre-cal coming in handy here. It becomes then the square root of sine squared x over the square root of 1 plus the cosine, and then again dx. But the square root of a sine squared is just sine by itself. Okay, so you're going to have pi over 3 to pi over 2, and you're going to have the square root of sine squared, so that's just a sine of x, and I can write the dx on top, square root of 1 plus the cosine of x in the bottom. All right, so what I'm going to do now is I'm going to do some u substitution. All right, I'm going to do some u substitution, and I'm going to say, okay, all right, and actually, did I do this right? Actually, no. This down here should be 1 minus. I don't know what I was thinking. All right, so I know I messed up there. All right, so let's just fix that right now. Shouldn't be plus, it should be minus, because the only thing you can multiply this by is a factor of 1. All right, that's why it has to be the same on top and the same on bottom. All right, so forgive me for that small error. I was like, something doesn't seem right, something seems fishy, but there it is, 1 minus the cosine of x. There we go, looks much better. All right, so now let's do some u substitution. All right, let's take a look. This 1 minus the cosine, that's going to be our u. 1 minus the cosine of x. And so if I take my du, derivative of cosine is negative. The sine, derivative of 1 is 0, so we don't worry about that. But the derivative of cosine is negative. The sine, that means that negative times negative makes for a positive sine x dx. And what do you know? I have right here sine x dx, my du, and this is my u. So I have basically a u to the 1/2 power in the denominator, so it's u to the minus 1/2 is what I'm going to be integrating. All right, when you think about this, this is u to the 1/2, but when you want to bring it up to the top, it becomes u to the negative 1/2, if you think about it already like that. All right, so what I'm going to do is I'm going to adjust my limits of integration, where before I was going from pi over 3 to pi over 2. What does my u go to? So 1 minus, in this case, cosine of pi over 3. All right, well, cosine of pi over 3, I believe, is 1/2, right? Is 1/2. So what do I get? Okay, cosine of pi over 3 is 1/2. 1 minus 1/2 is 1/2. There you go. Now, 1 minus the cosine of pi over 2. Cosine of pi over 2, I believe, is 0. So 1 minus 0 is 1. So we're going to integrate now from 1/2 to 1. And this is going to be very nice because it's a very simple and straightforward integral. 1/2 to 1. We have u to the negative 1/2 du, and no need to back substitute. This is a very simple straight up power rule integral. All right, u to the negative 1/2, you add 1 to the exponent, it gives you a u to the 1/2 power divided by 1/2, which is the same as multiplying by 2, evaluated from 1/2 to 1. All right, so what do we get then? We get something that looks a lot like this. 2, all right, because you plug in your 1, So 2 square root of multiplied by the square root of 1 is 1, right? And let's see here. What do we get? 2 minus, all right? And then it's going to be another 2 multiplied by 1 over the square root of, no, let's see, it's half, the square root of half. There we go. That's what it looks like. All right. But when you think about the square root of half, this is just 1 over the square root of 2. Because the square root of 1 on the top in the numerator is 1. So let's write that, 2 minus 1. And then the square root of 2 in the denominator. There we go. And we multiply that by 2. All right. So let's see here. What do we have? We have a 2 minus 2. And then it's over square root of 2. But we know we shouldn't have a square roots in the denominator. So this is going to give me what? 2 minus. This right here becomes a 2. These 2's cross out. 2 minus the square root of 2 then as my result. All right. Of my integral. All right. Again, applying those fancy identities from pre-cal. But I think we have time for one more example. So let's go ahead and take a look at another. All right, let's take a look at this one, number 6. We have the integral of tangent to the 4th power of 9t dt. All right, a tangent integral. Interesting. Well, I'm going to break this one up. All right, I'm going to break this one up very nicely because I see here that it's tangent to the 4th. So I'm going to break it up as tangent squared times tangent squared and then see where I can go from here. All right, because I'm still thinking pre-cal and I'm thinking there's got to be an identity. And there actually is. So here's what I need you to recall at this point from pre-cal. I need you to recall that the tangent squared, all right, of x equals the secant squared of x minus 1. Okay? The tangent squared x equals the secant squared x minus 1. So I'm going to rewrite one of these tangents as this secant squared minus 1. All right? And when I do that, I'm doing that because I start seeing u substitution. All right? So let's take a look. This one is a little bit more difficult, but we're going to handle it. Okay, so again, this one's indefinite, so that's really nice. We're not going to have to go back and evaluate this one. But let's write it as the secant squared of 9t minus 1, okay, multiplied by tangent squared of 9t dt. Okay, so what does this look like? All right. This looks like the following. I'm going to distribute this and make 2 separate integrals. Okay, so let's see here. What do I got? I've got the integral of secant squared 9t tangent squared of 9t dt. Okay, minus, okay, the tangent squared times the 1, so minus an integral of tangent squared 9t, okay, dt. So 2 separate integrals. But again, I'm going to recall my integral here, or not my integral, my identity for tangent squared, and that is that this is actually going to be another secant squared of 9t minus 1 dt. Okay, so let's see what this looks like when I put it all together. All right, what does it look like? Okay, let's take a look. Okay, so what I'm starting to see here is again that u substitution, and I'm going to look at this right here. I'm going to take this and I'm going to say this looks a lot like my u. So if u equals the tangent of 9t, what would my du look like? Well, my du would equal something like secant squared of 9t times 9 dt. Well, I've got my secant squared. It's right there. I just need the 9. So by consequence, a 1/9. So then this right here is my du. Okay, there's my du. All right, that one's okay. All right, now the next one is an integral of secant squared of 9t minus 1. So I'm actually going to break this up as well. And I'm going to break it up as a secant squared of 9t dt minus the integral of 1 dt. And you're going to see why in a minute, because I can actually take an antiderivative of secant squared. Okay, I can. All right, so let's take a look first at our u substitution. We're going to have a 1/9, the integral. All right, and it's going to be, let's see, u squared du. All right, that's nothing difficult. And then let's see here, minus the integral of secant squared 9t dt minus the integral of a 1 dt. We're going to look at each of these now in isolation. We have a 1/9, and then u squared becomes u cubed over 3 minus the integral of secant squared of 9t is just what? A tangent of 9t. Okay, so it is a tangent. But again, I'm going to need a 9 here. I'm going to need a 9, and by consequence, a 1 out of 9 there. All right, because of the chain rule in reverse. All right, so 1/9, and then there's my tangent of 9t. Okay, and then the integral of 1 is just going to be a t, so minus t plus c, your constant of integration. And now all we have left to do is back substitute the u that I didn't go back to do in just a while ago, but there it is. We're going to have 1 over 27 because 9 times 3 is 27. U in the first case was tangent, so it's going to be tangent cube of 9t plus, minus 1/9 tangent of 9t minus t plus c. Let's see here. And that right there is my result for my integral. Again, it was pretty monstrous. Lots of identities in play here, but overall it worked out very well. As always, I hope this video was helpful. And remember, like and subscribe.